Question number 1. The manager of an automotive company is interested in comparing the gas mileages for cars manufactured in country A and cars manufactured in country B. The manager selected a random sample of 100 cars. I'm going to just underline that. That's the sample size from country A, and a random sample of 100 cars manufactured by country B. The gas mileages for each sample in miles per gallon are summarized in the box plots. So they've given two parallel box plots for country A and country B's distribution. Now, whereas the question is compare the distributions of gas mileage for the sample of cars manufactured in country A and the sample of cars manufactured in country B. Now, as soon as you see compare the distribution, you should be thinking about SOX, which is shape, outlier, center, spread, using context and comparative terms. Now, let's see how to do this. Now, when it comes to describing the shape using a box plot, it does not precisely convey the shape of a distribution because it does not show where the data points are. So we cannot say if there is any gap in the distribution or if the distribution is single peaked or if it has more than one peak. However, we can find if the distribution is skewed to the right or left looking at the box plot. So now look at the first box plot for country A. The distance from the median to the maximum is greater than the distance from median to the minimum, indicating that the skewness is towards the increasing side or skewed to the right. Now for country B, on the other hand, the distance from the mean to the maximum is less compared to the distance from median to the minimum, indicating that the skewness is towards, or the tail is towards the decreasing side or skewed to the left. Now let's look at the outlier and the center of the distribution. If you look at country A, you can see there is an outlier at 38, and the center of the distribution for country A is at 18 miles per gallon. And for country B, there are no outliers, and the center is at 32 miles per gallon. Lastly, let's look at the spread of the distributions. So we can measure the spread using IQR. For the distribution of country A, the IQR, which is Q3 minus Q1, which is 24 minus 16, that is 8 miles per gallon. And for country B, which is 36 minus 24, that is 12 miles per gallon. Now let's put it all together. So this is a sample answer of describing or comparing two distributions. So the first one is the shape. The distribution of gas mileage for the sample cars produced in country A, which is your context, is roughly skewed to the right. Always when you are describing a shape, use the ly word like roughly or strongly, approximately, and so on. So it's roughly skewed to the right, indicating that most cars have lower gas mileage, with a few having much higher values because you have your cluster towards your left side. In contrast, which is a comparative term, the distribution of country B is slightly skewed to the left, suggesting that most cars have higher gas mileage with a few having lower values. You don't really have to write the suggesting that most cars have higher gas mileage. This is just to make inference if you have to compare the distribution and make an inference about the performance of the car. This is going to help you. Next is outliers. The box plot for the distribution of gas mileage for country A shows one high outlier. Again, I added some context. On the other hand, the distribution of country B has no outliers, suggesting a more consistent range of gas mileage among cars. Again, it shows that country B has better performing cars compared to country A. Now, the center of the distribution, the median gas mileage for cars produced in country A is 18 mpg, which is significantly lower, which is the comparative term again, than the median gas mileage for cars produced in country B, which is 32 mpg. Now the spread. The IQR of country A's distribution is 8 miles per gallon, which is smaller. Again, I used a comparative term than IQR for country B's distribution, which is 12 miles per gallon. So this suggests that the gas mileage for the middle 50% of the distribution is higher for country B. So overall, country B's cars scores better in performance compared to country A cars. Now let's move on to part B. For the distribution of gas mileage for the sample of cars manufactured in country A, would you expect the mean to be greater than 18 or less than 18 or equal to 18 miles per gallon? Justify your answer. Now let's look at the distribution once again. And let's look at country A's distribution. So the country A has a median of 18 miles per gallon. So the question is mean going to be greater than, less than, or equal to the median? So to decide that, we have to see whether the distribution is skewed to the right or to the left. And we can see that for country A, the distribution is skewed to the right. And we know the distribution is skewed to the right, mean moves towards the direction of the skewness or outliers. So the mean is going to go past the median, or it's going to be more than the median of 18 miles per gallon. So our answer would be, given the distribution of gas mileage for cars produced by country A is skewed to the right, we would expect the mean to be greater than the median gas mileage of 18 miles per gallon. This is because the median is not affected by the value of data points. It's affected by the number of individuals, not by the value of those points. That means either skewness or outliers. Median doesn't get affected. On the other hand, the mean is pulled to the right by higher gas mileage values in the tail and the high outlier, resulting in a mean that is greater than the median. Okay, now part C. The manager will create a new box plot with the combined data from the sample of cars manufactured in country A and the sample of cars manufactured in country B. In part 1, we have to find what is the range of the combined data set. Justify your answer. Now let's look at the distribution once again. Now when you combine two data sets, to find the range of the combined data set, we have to look at the minimum of the overall minimum of the two data sets, which is 14, and the overall maximum of the two data sets, which is 40. So the combined range would be, the range of the combined data set would be 40 minus 14, that is 26 miles per gallon. Now, second part of C, what is the possible value of the median of the combined data set? Justify your answer by referencing the box plots shown. So this is a little bit trick question. This is where you could have made a mistake by adding the two medians, or finding the average of the two medians, or finding the range and then dividing that by 2 or something like that. So one thing that you need to know about the median is a point that splits the distribution into two halves. That means 50% of the data values would be left of the median and 50% of the data values would be to the right of the median. So let's look at the distribution once again. So now we have country A, 100 cars, and country B has 100 cars. Now, if you combine the two distributions, you will have 200 cars in total. So we have to find a point which splits the distribution in such a way that you get 100 cars on the left of that point and 100 cars on the right of that point. So let's look at the distribution. So let's look at country A. You know that from minimum to quarter 3, you have 75% of the data values, which is 75% of 100, that is 75 cars right there. Now, when you combine the two distributions, you will get 200 cars, and half of that would be 100 cars. So 100 cars to the left of the median, and we need to have 100 cars to the right of the median. Now, let's look at country B. that is minimum 2/4 1, which is 25% of the distribution. That is 25% of 100, which is 25 cars. Now you can see that below 24 miles per gallon, you have 100 cars. When you combine the two data sets, country A and country B, you get 100 cars below 24. Now let's see above 24. If you look at country A from Q3 to maximum, which is an outlier, doesn't matter, you will have 25% of the total number of cars, which is 25. And from Q1 to maximum for country B, you will have 75% of the total, which is 75% of 100, which is 75. Now, if you add them both, you're getting 100 cars to the right of 24 and 100 cars to the left of the 24. So 24 might be the plausible median. So the answer might look like this. So median being the equal area point when you combine the two distributions of gas mileage for country A and country B cars. 50% of 200, which is 100 cars, will be on the left of the median, and 100 cars would be above the new median. So looking at the box plot, so we have to reference the box plot. Looking at the box plot, there are 100 cars below 24 mpg and 100 cars above 24 mpg in the combined data set. So the plausible median of the combined distribution would be 24 mpg.